So picture this. A strange flash on a NASA live feed, a world-renowned physicist issues a cryptic warning, and suddenly, everything we thought we knew about the moon is just, well, wrong. For decades, there have been whispers, odd signals, unexplained events, but now, the data is undeniable. The moon isn't the dead, silent rock we always imagined. It's active, it's unpredictable, and honestly, it might be far more dangerous than we're being told. As we race to build a permanent base on its surface, are we ignoring the signs? Let's delve into it. Historical context: Apollo's ringing bell. Think the moon is just a lifeless ball of rock? Well, the Apollo astronauts thought so too, until they performed an experiment that, frankly, sent shockwaves through mission control. On November 20th, 1969, the Apollo 12 crew deliberately crashed their 2,400-kilogram lunar module into the surface at over 6,000 kilometers per hour. Gary Latham, the principal investigator for the Apollo seismic experiments, and his team expected a brief tremor that would fade in minutes. Instead, the moon resonated like a giant gong. The single seismometer, placed just 73 kilometers away, detected vibrations that continued for a staggering 55 minutes. And get this was repeated on later missions with even larger impacts. When the 14,000-kilogram SVB booster from Apollo 14 hit the moon, the vibrations lasted for over 3 hours. On Earth, with its water and fractured geology, such an impact would have died down in less than 5 minutes. The moon's prolonged ringing, according to Latham's team, suggested the lunar crust is incredibly rigid and fractured, allowing seismic waves to travel vast distances without losing energy. This was the first hard data, suggesting our celestial neighbor was far stranger and more structurally uniform than anyone had imagined. AI surveillance systems. In the 21st century, we don't just rely on human eyes to watch the skies. So, who's watching the moon when we aren't? The answer is artificial intelligence. Sophisticated AI systems now monitor continuous data streams from lunar orbiters, which have sent back over 1.4 petabytes of data. That's 1,400 terabytes. These neural networks, developed by scientists like Dr. Kiri L. Wagstaff at NASA's Jet Propulsion Laboratory, are trained on millions of high-resolution images to detect patterns and anomalies a human operator would almost certainly miss. You can think of it as the ultimate security camera for our celestial neighbor, with a resolution capable of spotting objects as small as 50 centimeters. These systems aren't just looking for craters. They're hunting for outliers in thermal, spectral, and topographic data. They can distinguish between a 1-millisecond cosmic ray strike, a camera glitch, and a genuine surface phenomenon with over 98% accuracy. When an AI flags an event like the one that triggered this warning, it's because the event breaks established patterns across multiple data types simultaneously, giving us a new, unbiased look at what's really happening up there. The moon is alive. Was the ringing bell of the Apollo era just an old mystery? Not at all. It was a warning shot. Recent missions have confirmed that the moon is far from geologically dead. India's Chandrayaan-3 mission, which landed in August 2023, detected numerous seismic events. This data is critical because it confirms what scientists like Dr. Thomas Waters of the Smithsonian have been arguing for years. Waters and his team have identified thousands of fault scarps, particularly concentrated near the South Pole. These aren't ancient. They are signs that the moon is actively shrinking as its core cools, causing its diameter to have decreased by about 50 meters over the last few 100 million years. This shrinking causes the crust to break, triggering shallow moonquakes that can register up to 5.5 on the Richter scale, powerful enough to cause significant damage. One major quake near the South Pole is estimated to have occurred less than 50 million years ago, a blink of an eye in geologic time. This is precisely where NASA's Artemis program plans to build its base. The moon groans, it trembles, and it is very much alive. Underground mysteries. If the surface is more active than we thought, what's happening underneath? The answer might be even more unsettling. Decades of data have pointed to the existence of enormous caverns beneath the lunar crust. These are not small caves, they are massive lava tubes. Planetary scientist Dr. Pascal Lee of the SETI Institute has studied these features as potential habitats because they offer incredible protection, reducing lethal radiation exposure by a factor of 1,000 or more, and providing a stable temperature of around -20 degrees Celsius, compared to the surface which swings from 120 degrees Celsius to -170. but their scale is honestly terrifying. Japan's Kaguya orbiter discovered a lava tube in the Marius Hills region that is estimated to be over 50 kilometers long and at least 1 kilometer wide, large enough to fit the entire city of Philadelphia inside it. NASA's Grail mission confirmed these massive hollow spaces stretch for miles. Here's the concerning part. These voids are concentrated in the same regions as the most intense seismic activity. Imagine building a habitat on what appears to be solid ground, only for a magnitude 5.5 moonquake to collapse the kilometer-wide cavern beneath you. The invisible killers. There are dangers on the moon that you can't see, hear, or feel until it's too late. The biggest threat isn't a moonquake, it's cosmic radiation. Unlike Earth, the moon has no protective magnetic field. Space radiation expert Dr. Carrie Zeitlin has noted that the average daily radiation dose on the moon is about 1,369 microsieverts, over 200 times more than on Earth's surface. But the real killer is a solar particle event, or SPE. During a major solar flare, the surface is blasted with particles traveling at nearly the speed of light, and the radiation dose can spike to over 1 sievert. That's a potentially lethal dose, causing severe radiation sickness, with a 15% chance of death within 30 days, delivered in a matter of hours. These events are often invisible, but they can leave a signature on camera feeds as bright flashes. By the time you see the flash, the lethal radiation has already arrived. With our sun entering a more active solar cycle, the frequency of these deadly invisible storms is predicted to increase by over 30%. The hidden race for control. While scientists debate natural phenomena, another possibility for strange anomalies cannot be ignored. Some might not be natural at all. We are no longer alone in our lunar ambitions. The moon has become the arena for a new, high-stakes space race. Both the United States and China are targeting the South Pole, where an estimated 600 billion kilograms of water ice may be trapped in permanently shadowed craters. General David D. Thompson of the U.S. Space Force has spoken publicly about China's capabilities to interfere with U.S. activities. NASA's Artemis 3 landing is planned for no earlier than September 2026, while China plans to establish its International Lunar Research Station in the same region in the 2030s, in partnership with Russia. The Outer Space Treaty of 1967 forbids national appropriation, but it's silent on resource extraction, creating a dangerous legal gray area. An unexplained flash on a live feed could be more than a cosmic ray. It could be a reflection from a surveillance platform no one is ready to publicly admit. Historical patterns. Transient lunar phenomena. Strange lights on the moon are not a new occurrence. For centuries, astronomers have documented what are known as transient lunar phenomena, or TLPs. These are short-lived changes in light or color on the lunar surface. On May 4, 1787, Sir William Herschel, the discoverer of Uranus, reported observing what he believed were 3 volcanoes erupting on the moon. In the 1960s, NASA commissioned a study which resulted in the technical report R277, a catalog compiled by astronomer Winifred Sawtelle Cameron listing 579 reliably observed lunar events. These sightings often cluster around specific geologically interesting regions like the crater Aristarchus, a hotspot for TLP reports. One leading theory, championed by planetary scientist Dr. Arlen Kratz, is that these flashes are caused by the release of ancient gases from below the surface which kick up dust that reflects sunlight. During the Apollo 11 mission, Mission Control alerted the crew to a TLP report from German astronomers who had just observed a bright glow near that very crater. Apollo-era secrets. The scientific instruments of Apollo told a story of a surprisingly active moon, but what about the astronauts? The men who walked on it also reported seeing things they couldn't explain. Crew members described seeing strange flashes of light even with their eyes closed. These were high-energy cosmic rays, with energies exceeding 100 mega-electron volts, striking their retinas. However, some flashes were observed externally. During the Apollo 17 mission in December 1972, astronaut and trained geologist Dr. Harrison Schmitt yelled, "I just saw a flash on the surface," while orbiting the moon. Schmidt's scientific background made his observation particularly credible. He reported the bright pinprick of light near the crater Grimaldi. His fellow crewmate Ronald Evans also spotted a flash east of Mare Orientale. These were experienced observers, not prone to exaggeration. Their reports, combined with the seismic ringing data, painted a picture of a moon that was far more dynamic than the magnificent desolation it appeared to be. Why it matters to you. This isn't just about strange lights 384,400 kilometers away, it's about the future of human exploration. We are returning to the moon, and this time, the plan is to stay. The Artemis program, with a projected cost of $93 billion through 2025, is a massive global investment in our multi-planetary future. The technologies we are developing, quake-resistant habitats, radiation shielding, closed-loop life support systems, are the same technologies that will one day take us to Mars. But as space policy expert Dr. Bhavya Lal has emphasized, the success of these missions depends on accurate risk assessment. What if that assessment is flawed? Building a base on ground that is unstable, riddled with voids, and blasted with radiation is a recipe for disaster. The investment is immense, but the potential return in scientific discovery, technological advancement, and securing humanity's future beyond Earth is incalculable. Getting the moon right is the critical first step. The terrifying reality. Let's connect the dots. The terrifying warning from physicists like Michio Kaku isn't about a single event. It's the conclusion drawn from over 60 years of accumulated data. The Apollo experiments proved the moon has a bizarre internal structure that rings for up to 3 hours. Modern seismometers confirm it can produce magnitude 5.5 quakes right where we plan to land. Orbiters have mapped 50-kilometer-long hollow lava tubes beneath that same region, creating a risk of catastrophic collapse. We know the surface is constantly bombarded by radiation, with a single solar storm capable of delivering a lethal 1 sievert dose in hours. And on top of all these natural dangers, the moon is now a theater for a geopolitical space race involving more than a dozen nations. Each one of these facts is a serious challenge. Together they paint a picture of an environment far more hostile and unpredictable than we have publicly acknowledged. The flashes and anomalies are symptoms of a deeper truth. The moon is not a stable, dead world, it's an active, dangerous frontier. The evidence is clear. The moon holds secrets we are only now beginning to unravel. The consistent pattern of anomalies from the Apollo era to today's AI-monitored feeds tells a story of a world that is active, complex, and potentially treacherous. As we prepare to send the next generation of explorers back to the lunar surface with the Artemis program, we must proceed with caution and a newfound respect for the challenges that await. The stakes, human lives, national investment, and our future in space, are simply too high to ignore the warnings. If you found this exploration as fascinating as we did, don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. What do you think the moon is trying to tell us? Thank you for watching Space Facts. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. Swan's dramatic arrival. What if a new object appeared in the sky tonight so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropes or Swan instrument, a wide-field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous Comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or Swan in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but Swan was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arcseconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025 R2 or Swan wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. Swan's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. Swan will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with Swan tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So what happens when an object just, flat out refuses to follow the laws of physics as we know them? Well, that's exactly what happened with 3 I/Atlas, which first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms everywhere. A body dominated by nickel with virtually no iron, a ratio that's pretty much unheard of in natural celestial objects. This completely contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends similar to chondritic meteorites. The claim was so radical, some labs immediately called for data re-verification just to make sure there wasn't some kind of mistake. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. And what really couldn't be explained was its motion. Observers noted 3 distinct, non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object to show similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. One object acts like a drone, the other like a battleship. C/2025 R2 or Swan is honestly in a league of its own. Its sheer scale is breathtaking, but it's really the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo or reflectivity of 0.6, similar to fresh snow. That's wild, considering typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, a material we use on Earth for its immense strength and resistance to corrosion. This is what led to the term nickel-cobalt hull popping up in online forums, Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. That's actually where the nickname the Fortress comes from. Unlike the agile Atlas, Swan moves like a tank, slow, steady, and honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of micro-thrusts, tiny, rhythmic pulses that suggest precision course corrections, which are way too regular to be just random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really start to plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the Sun acting as a cosmic pit stop for two engineered probes. A second, less peaceful theory, suggests an intervention or a confrontation, especially when you consider the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I 2017 U1, was the first scout, followed by 2I Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the Sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or an energy top-up is standard practice for our own probes, like the Parker Solar Probe, which honestly makes this theory chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Swan's enormous 22,554-year orbit is, a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, and some of these are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are speculative. Still, the timing is, well, hard to ignore. Swan's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. Power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But Swan makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Space Facts. It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I/Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I/Oumuamua in October 2017 and 2I/Borisov in August 2019, the arrival of 3I/Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I/Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I/Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I/Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I, Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3I Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, The object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated materials science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3I Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes, suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3i Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts.